Okay, today we are going to discuss about the incidence, reflection and refraction of waves in the case of a transmission systems. Okay, first what is meant by the incidence and what is meant by the reflection and what is meant by the refraction. Okay, how why it will be obtained in the case of a transmission line and what is the voltage the equations for that incident wave, reflected wave and refraction waves. Okay, first when a traveling wave is turned into medium which has a different impedances. Okay, when the traveling wave that is transmitted in the medium. Okay, medium means the traveling wave is transmitted by using the conductors. Okay, which has a different impedances. Okay, if a traveling wave arrives at a point where the impedance is suddenly changes the wave. Okay, is partially transmitted and partially reflected. Okay, that wave is partially transmitted and also that wave is partially reflected. Okay, the impedance wave meeting along a line will contains in accordance with their polarities. Okay, first of all, what is meant by the incident wave, what is meant by the reflection wave and what is meant by the refraction wave. Okay, if the wave is reflected, the corresponding voltage and currents are in the opposition polarities. Okay, the corresponding voltage and currents are in the opposition polarities. Okay, when the traveling wave is turned into another medium, that means suppose that wave is transmitted from one medium to another medium which has a different impedances. Okay, that means first medium has the some impedance and the traveling wave is shifted for that another medium, then it having the another impedance. Okay, then the original medium, then the part of the wave is the reflected back. Okay, then the part of the wave is reflected back and the part of the wave is transmitted into the another medium. Okay, some wave is reflected back and some wave is transmitted to the another medium. Okay, that reflected back waveform is called as the reflected wave. Okay, the transmitted wave is called as the incident wave. Okay, the transmitted wave is called as the incidence wave. Okay, when the traveling wave is terminated into the another medium, in that case the impedance values also changes. Okay, due to the changing of that impedances, due to the changing of that impedances, some wave is reflected back. Okay, some part of that wave is traveling wave is reflected back. Okay, that is called as the reflected wave. Okay, and the some part of the waveform is transmitted to another medium. Okay, that waveform is called as the incident wave. Okay, that in that waveform is called as the incident waveform. Okay, the incoming wave is called as the incident wave. Okay, the incoming waveform means that will be transmitted into the another medium. Okay, which waveform is transmitted into the another medium, that is called as the incoming wave. Okay, that is also called as the incident wave. That is called as the incident wave. Okay, and the reflected and the transmitted waves are called as the reflected waves. Reflected waves and also refracted waves. Okay, the transmitted wave and also the reflected waves is also called as the reflected and the refracted waves. Okay, reflected and the refracted waves. Okay, therefore the value of refracted wave can vary from 0 to twice the value of the incident wave. Okay, what is meant by incident wave? Some waveform is transmitted through the same another medium. Okay, that waveform is called as the incident waveform. Okay, that waveform is called as the incident waveform. Okay, that incident waveform depending upon the impedance of the medium. Okay, that incidence waveform will be depending upon the transmitted medium. Okay, first of all, what is meant by the incident waveform? Incident waveform means the traveling wave is terminated into the another medium which has divided into the two parts. Okay, one is the reflected back. One part of that waveform is the reflected back, and the other part of the wave is the transmitted into the another medium. Okay, that waveform is called as the incident waveform. Okay, that waveform is called as the incident waveform. Okay, the value of refracted wave can vary from the 0 to twice the value of the incident wave. Okay, therefore the reflected wave can vary from the 0 to twice the value of the incident wave. Okay, that changing will be depending upon the impedance of the medium. Okay, therefore the changing is depending upon the incidence of that medium. Okay, first, what is meant by the refracted and the refraction of that waves? Okay, that incident waves that incidence waves is reflected to the some another part of the traveling wave. Okay, that waveform is called as the reflected wave. And also the refraction wave means the some part of that wave is refraction to the transmission line. Okay, that the following refractions are holds for that reflection wave is in the negative sign direction. Then the voltages and currents are represented like below this. Okay, first the line of the characteristic impedance is the Z1. Okay, suppose we assume the characteristic impedance is the Z1. Okay, is termed by a line of impedance of Z0 and the incidence waves. Okay, has a voltage of V. Then the voltage equation of that reflected and the refracted waves are this is the voltage equation for that reflected wave, and this is the voltage equation for that refracted wave. Okay, reflection means the coming back. Okay, the waveform is coming back from output side to the input side. Okay, that waveform is called as the reflected wave. Okay, due to that reflected wave, some refractions are to be obtained in that wave, that is called as the refraction waveform voltages. Okay, that is called as the refraction waves. Okay, therefore V reflected is equal to the V into Z0 minus Z1 by Z0 plus Z1. Okay, then V refracted is equal to the V into 2Z0 by Z0 plus Z1. Okay, 2Z0 by Z0 plus Z1. Okay, where Z0 is the line impedance. Okay, therefore the Z0 is the line impedance, and Z1 is termed as the characteristic impedance. Okay, Z0 is the line impedance and Z1 is called as the characteristics impedance. Okay, therefore the reflected and the refracted waves are depending upon the line impedance and also the characteristic impedance. Okay, it will be depending upon the line impedance and also the characteristic impedance. Okay, therefore what is meant by the refraction and refracted waves means okay, if the traveling wave arises at a point. Okay, suppose the traveling wave is starting from a particular point where the impedance is suddenly changes. Okay, suppose that impedance values are suddenly changes. Okay, therefore the wave is partially transmitted and partially reflected. Okay, some part of that wave is partially transmitted and some part of wave is partially reflected. Okay, that partially transmitted wave is transmitted for that another impedance. Okay, that partially transmitted wave is transmitted by using the another impedances. Okay, if a traveling wave arises at a point, okay, suppose at a particular point the traveling waves are developed. Due to that traveling wave, some part of the waveform is partially transmitted and some part of the waveform is partially reflected. Okay, the transmitted waveform is transmitted for that another impedance line. Okay, the transmitted wave is transmitted by using the another impedance line. Okay, it is the loading points and the line cable junctions. Okay, therefore the impedance waves meetings along a line will combine in accordance with their polarities. Okay, that impedance waveform is depending upon according to their polarities to provide the different voltage and current levels. Okay, that impedance wave will be depending upon the polarities of that voltage and the current waveforms or current values. Okay, it is convenient to adapt a standard sign convention. The forward waves of that voltage and currents are given as the same polarities. Okay, let's suppose we are taking the E and I. Okay, represent the incoming and outgoing lines, represent the transmitted waves. ER and IR are the reflected waves. Okay, therefore the ER and IR are the reflected waves and ET and IT are the transmitted waves. Okay, E and I are the incidence waves. Okay, E and suppose we are assuming the E and I are the incidence waves and ER and IR as the reflected waves and ET and IT are the transmitted waves. Okay, therefore ET and IT are the transmitted waves. Okay, we are assuming E and I are the incidence waves, ER and IR are the reflected and transmitted waves for voltage and currents, and ET and IT are the reflected and transmitted of that current and the voltages. Okay, therefore the following relation holds good for incident, transmitted and reflected voltage and current values, current waveforms. Okay, it is the reflected voltage and current waves. Okay, therefore we are assuming or we are taking that one impedance value that is called as Z. Z is the impedance and this is the open circuited, in that voltage is the E. Okay, at that the characteristic impedance we are taking as the ZC. Okay, then we write down the equations for that incident voltage, transmitted voltage and also the reflected voltages. Okay, this is the incident voltage E and this is the transmitted voltage E and this is the reflected voltage E. Okay, therefore normally we well known about the voltage V is equal to the I into R. Okay, instead of R, we are taking as the ZC, that is the characteristic impedance. Therefore, E is equal to the I into ZC. Okay, E and I are the incidence voltage and current values, and ZC is the characteristic impedance. Okay, therefore, the ZC is the characteristic impedance. Okay, this is the equation number 1. Okay, next write down the equation for that transmitted voltage. Okay, next write down the equation for the transmitted voltage, that is the ET. Okay, that is the ET. Okay, ET is the transmitted voltage. Therefore, ET is equal to the IT into ZC. Okay, ET is the transmitted voltage and IT is the transmitted current. And Z is the impedance and Z is the impedance. Okay, next write down the equation for that refracted voltage ER. Okay, refracted voltage ER. Therefore, ER is equal to the minus IR into ZC. Okay, therefore, ER is equal to the minus IR into ZC. Okay, this is the equation number 3. Okay, this is the incident voltage and this is the transmitted voltage or the reflected voltage. These are the reflected voltage and ER is the refracted voltages. Okay, ER is the reflected voltages. Okay, negative sign equation 3 is because of the fact ER and IR are the traveling in the negative directions. Okay, negative ER means that the ER and IR are traveling in the negative directions. Why? Because that will be traveled in the negative direction means that the waveform is refracted back. Okay, that waveform is refracted to back. That's why it is called in it is that's why it is represented as the negative sign. Okay, that's why it is represented in negative sign. Okay, therefore ER is equal to the minus IR into ZC. Okay, ER is equal to the minus IR into ZC. Okay, negative sign in equation number 3 is the because of the fact that ER and IR are the traveling in the negative directions. Okay, negative direction indicates the backward direction. Okay, negative direction indicating the backward direction. Okay, that's why we are taking as the minus value in that equation number 3. Okay, that's why we are taking the minus value in equation number 3. Okay, next we write down the transmitted voltage ET. ET is equal to the E plus ER. Okay, transmitted voltage is equal to the transmitted voltage ET is equal to the E. E is the incident wave. E plus ER. ER means the refracted wave. Okay, ER means the reflected wave. Okay, then substitute same as that of we write down the IT. IT is equal to the I plus IR. Okay, therefore IT is equal to the I plus IR. Okay, this is the equation number 4 and this is the equation number 5. Okay, by substituting the values of I, IR and IT from the equation number 1 to 3 in equation number 5. Okay, substitute the values for that IT, IR and other I values in equation number 5. Okay. By using these equations, first we write down the from equation number 2, IT is equal to the ET by Z. Okay, from equation number 2, okay, from equation number 2, we write down the equation for that IT. Okay, we write down the equation for that IT. Okay, then IT is equal to the, okay, therefore, IT is equal to the ET by Z. IT is equal to the, okay, ET by Z from equation number 2. Okay. ET by Z. Okay, substitute this IT and also I, okay, and also IR. Okay, what is that I? I is equal to the E by ZC. Okay, what is that IR? IR is equal to the minus ER by ZC. IR is equal to the minus ER by ZC. Okay, substitute the values for that ET, sorry, I, IT, IR. Okay, substitute the values for that I, IT and also IR in equation number 5. Okay. In equation number 5. Okay, Okay, therefore, IT is equal to the ET by Z and I is equal to the E by ZC and IR is equal to the ER by ZC. IR is equal to the ER by ZC. Okay, substitute 1, 2, 3 in equation number 5. Okay, by using the 1, 2, 3 equations, we find out the IT, I and the IR. Okay, and then substitute that values in the equation number 5. Then we obtain ET by Z is equal to the E by ZC minus ER by ZC. Okay, minus ER by ZC. Okay, this is the equation number 6. Okay, this is the equation number 6. Okay, from equation number 4, what is that equation number 4? ET is equal to the E plus ER. Okay, from equation number 4, the equation 6 can be rewritten as ET by Z is equal to the E by ZC minus substitute ET by Z. Okay, substitute ER. Okay, substitute that ER value from equation number 4. ER is equal to the ET minus E. Okay, from equation number 4, we write down the ER equation. Okay, therefore, ER is equal to the ET minus E. Okay, then substitute replaced ER by ET minus E. Okay, replace ER value with ET minus E. Okay, therefore ER is equal to ET minus E by ZC. Okay, ER is equal to ET minus E by ZC. Okay, ER is equal to ET minus E by ZC. Okay, by simplifying this equation, ET, okay, ZC by Z is equal to 2E minus ET. 2E minus ET. Okay, then substitute. Okay, then substitute the value, that is 1 plus ZC by Z equal to 2E. Okay, then we write down the equation for that ET. Therefore, ET is equal to E into 2 Z by Z plus ZC. Okay, E into 2 Z by Z plus ZC. Okay, this is the equation number 7. Okay, this is the equation number 7. Okay, next write down the IT. Okay, what is that IT? IT is equal to the ET by Z from equation number 3. IT. Okay, from equation number 5. Okay, from equation number 5, IT is equal to the ET by Z. Okay, IT is equal to the ET by Z. Okay, that is equal to, substitute ET value in this equation. Therefore, ET is equal to 2E by Z by Z plus ZC. Okay, then cancel Z then cancel, then we obtain 2E by Z plus ZC. Okay, by cancelling the Z and Z, then we obtain IT is equal to, okay, then we obtain IT is equal to the 2E by Z plus ZC. Okay, therefore IT is equal to the 2E by Z plus ZC. Okay, that is equal to 2ZCI by Z plus ZC. Okay, 2ZCI by Z plus ZC. Okay, 2ZCI by Z plus ZC. Okay, therefore, ER is equal to ET minus E. Okay, therefore, ER is equal to the ET minus E. Okay, that is equal to 2ZE by Z plus ZC. Okay, that is equal to 2ZE by Z plus ZC. Substitute, this is the ET value. Okay, in this equation, ET is equal to E into 2Z by Z plus ZC. Okay, substitute equation number 7 in this equation. Then we obtain 2Z E by Z plus ZC minus E. Okay, minus E. Okay, that is equal to E Z minus ZC by Z plus ZC. Okay, then it will be written Z minus ZC by Z plus ZC. Okay, then similarly we find out the IR. IR is equal to minus ER by ZC, or that is equal to minus E by ZC into into Z minus ZC by Z plus ZC. Okay, then simplify this. Then we obtain I into ZC minus Z by ZC plus Z. Okay, then we obtain ZC minus Z by ZC plus Z. Okay, this is the refracted current and this is the refracted voltage for that waveform. Okay, therefore the coefficients, that is the 2Z by Z plus ZC and Z minus ZC by Z plus ZC are called the coefficients of refraction and the reflection waves. Okay, are the coefficients of refraction and the reflection waves. Okay, once we check that derivation, first we write down E. Okay, V is equal to I into ZC. Okay, normally voltage V is equal to I into R. Okay, then we write down the E is equal to I into ZC and ET equal to IT into Z. Okay, ER is equal to minus IR into ZC. Okay, substitute, that is equation number 1, 2, 3. Okay, write down, that is equation numbers 1, 2, 3. Okay, and then we write down the ET. Similarly, we write down the ET. Okay, that is the transmitted voltage and currents will be respectively the algebraic sum of the incidence and the reflected voltages. Okay, E means the incident voltage and ER is the reflected voltages. Okay, and ET is the refracted voltages. Okay, normally the refracted voltage is equal to the incident voltage plus reflected voltage. Okay, ER is the reflected voltage, E is the incident voltage and ET is the transmitted voltage or the reflected voltage. Okay, transmitted voltage or the reflected voltage. Okay, therefore ET means the reflected voltage. ET is equal to the algebraic sum of the incident voltages plus reflected voltages. Okay, incident voltage plus the reflected voltages. Okay, therefore the incident voltage is the E. Okay, that's why we are writing, that is ET is equal to the ET is the refracted voltage is equal to algebraic sum of the incidence and the reflected voltages. Okay, it is the algebraic sum of the incidence and the reflected voltages. Okay, therefore ET is equal to E plus ER. Okay, similarly, we write down the current equation, that is IT. Okay, similarly, we write down the current equation, that is IT. Okay, therefore, IT is equal to the, IT is the reflected current. Okay, refracted current is equal to the incident current plus the reflected current. Okay, it is the algebraic sum of the incident and the reflected currents. Okay, it is the algebraic sum of the incident current and the reflected currents. Okay, substituting the values of I, IR and IT from the equation number 1, 2, 3. Okay, by using this equation number 1, 2, 3, we substitute the values for that IT and I and the IR. Okay, by using this equation number 2, we obtain the IT value. Okay, therefore IT is equal to ET by Z. Okay, then I is equal to E by ZC. Okay, IR is equal to ER by ZR. Okay, then substitute IT, I and the IR. Okay, IT means the refracted current. I is the incident current. IR is the reflected current. Okay, IR is the reflected current. Okay, that is Et by Z is equal to E by ZC minus Er by ZC. Okay, this is the equation number 6. Okay, and then substitute Er value from equation number 4. Okay, and then we write down the ER value by using equation number 4. Okay, what is that ER? ER is equal to ET minus E. Okay, then substitute ET minus E by ZC. Okay, ET by ZC is equal to E by ZC minus ET minus E by ZC. Okay, by using this equation, then we obtain the and substitute that values, that is 1 plus ZC by Z, and then obtain the ET value and the IT value. Okay, ET is the reflected voltage and so refracted voltage, and IT is the refracted current. Okay, refracted voltage and the refracted current. Okay, that is equal to E into 2Z by Z plus ZC. Okay, E into 2Z by Z plus ZC. Okay, then IT is equal to ET by Z. Okay, ET by Z, that is equal to 2E by Z plus ZC. Okay, that is equal to 2E by Z plus ZC, that is equal to 2ZC I by Z plus ZC. Okay, then ER is equal to ET minus E, and then IR is equal to minus ER by ZC. Okay, the coefficients of 2Z by Z plus ZC and the Z minus ZC by Z plus ZC are called as the coefficients of refraction and the refraction and the reflections respectively. Okay, it is the derivation for that voltages of a transmitted, that means the refraction, and also incident and also refraction voltages. Okay, in that the coefficients are the 2Z by Z plus ZC and Z minus ZC by Z plus ZC, okay, are called the coefficients of refraction and also the refraction of the waveforms. Okay, it is called as the coefficients of reflection and also the refraction of that voltages. Okay, it is the derivation for that incidence, transmitted and reflection voltages and the current equations. Okay, voltages and the current equations. Next, in the next class, we discuss about the typical causes of a line termination. Okay, that means the open circuit line and also the short circuit line. Okay, what are the difficulties that will be obtained when the open circuits lines are in the transmission systems? That will be discussed by using the some graphs, related graphs. Okay, and also we discuss about the short circuit lines. Okay, we discuss about the short circuit lines, and observe the variations of voltage and currents in the case of a open circuit ended transmission line, and also in the case of a short circuit ended transmission line. Okay, that will be discussed in the next class, that is the open circuited line and also the short circuit lines. Okay, this is the present class, that is the refraction and refraction and also the reflections of that waves. Okay, it is also called as the transmitted waves. Okay, first, what is meant by the incidence wave? Incidence wave means that in some cases the traveling wave is changes that medium. Okay, some part of the waveform is traveling to that another medium, that is called as the incident wave. Okay, that is called as the incident wave. Okay, this is the definition for that incident wave and reflected wave and also the refracted wave. Okay, refracted wave means that it is the algebraic sum of the reflected wave and also the incidence wave. Okay, it is the algebraic sum of the reflected wave, refracted wave and also the incident wave. Okay, it is the refracted wave. definitions. Okay, this is the derivation for that reflected and also the refracted waveform voltages and the current waveforms. Okay, this is the equation for that normal voltages for a incident wave, transmitted wave and also the reflected waves. Okay, in that reflected wave we are taking as the negative sign. Why? Because we are taking the negative sign means the that traveling waves negative direction for that x are the backwards for that line. Okay, that means the some part of the traveling wave is move away backward for that transmission line. Only some part of the wave is transmitted by using that transmission line by the another dielectric, another medium. Okay, that is called as the incident wave. Okay, that is called as the incident wave. Okay, that's why we are representing the negative sign, that means the backward direction. Okay, negative sign indicates the backward direction. Okay, this is the normal equations for that. This is the transmitted voltage that is equal to the algebraic sum of the incident voltages and also the reflected voltages, and this is the refracted voltage and the reflected current equations. Okay, refracted voltage and also the refracted current equations. Okay, in that equations the coefficients are the 2ze by z plus zc, and this is the z minus zc by z plus zc. Okay, these are the coefficients. Okay, these coefficients are called as the refraction and the reflections. Okay, these coefficients are called as the refractions and the reflections. Okay, this is the transmitted refraction and the reflections of that positive polarities. Okay, of that positive polarities. Okay, this is the derivation for that refraction and the refractions of that transmitted waves, wave polarities. Okay, therefore the polarities of the reflected wave depending upon the magnitude relationship between the zc and the z. Okay, where z is the impedance and also zc is the characteristic impedance. Okay, the polarities of that transmitted wave, the polarities of that reflected wave depending upon the magnitude of that transmission line, that is the zc and the z. Okay, if suppose zc is greater than the z, okay, if suppose the zc is greater than the z, then the voltage wave is negative. Okay, then the voltage wave is negative, and current wave is the positive. Okay, voltage wave is the negative and current wave is the positive, or the vice versa, or the reverse condition. Current wave is the negative and voltage wave is the positive. Okay, but vice versa, if z is greater than the zc. Okay, if z is greater than the zc, in that case only it is the vice versa. Okay, if zc is greater than the z, in that condition the voltage wave is the negative. Okay, if zc is greater than the z, okay, zc means the characteristic impedance is greater than the normal impedance. In that case the voltage wave is negative. The voltage wave is the negative. Okay, suppose the suppose z is greater than the zc. Okay, suppose the z is greater than the zc, that means the z is the normal impedance, zc is the characteristic impedance. Okay, suppose the z is greater than the zc, then in that case the voltage is the positive and current is the negative. Okay, in that case the voltage is the positive and current is the negative. Okay, that is the characteristic that is the incidence and refracted and refraction coefficients. Okay, that coefficients are depending upon the polarities. Okay, that is the either positive voltage or the negative voltage. Okay, that positive or negative voltages are depending upon the zc is greater than the z or zc is less than the z. At that situation the polarities are depending upon that impedance values. Okay, this is the derivation for that refracted and also refracted and also the incident voltage Okay, and also the incident voltages. Okay, in the next class we discussing about the open circuit and short circuit conditions for that traveling wave or the transmission systems. Okay.